Welcome back. In this third video of our series of dynamic simulation basics, we are going to make our Lego model to roll and to steer along 1 meter length. So, in order to make that happen, we need to modify our CAD models as we did in the second video. So you can download the CAD model in this link. Remember, this is native files, so they should work in Autodesk Inventor without problems. Okay, so let's start with the deletion of all these elements, and the idea is to insert them on the top level by making the correct mates, because maybe the mates that actually are on the original files maybe it's not the most convenient one. Okay, so it will be the steering system with the steering wheel and the axis. These other two pieces that are for the pivoting of the wheels. There you go. Then we have the rack, and that rack is going to be concentric with the corresponding geometry in the steering system, and it should be pivoting like I'm showing right now. And following, we are going to make an axis and point constraint on both sides. This is because the rack requires to rotate as I'm showing right now, and this is as simple as necessary because the real life part is plastic and it flexes as long as it do the steering. So having it totally rigid is not going to be possible, but is possible by doing it that way. Just an additional mate here is basically a motion mate that is going to came to life your steering wheel on the assembly environment, but it's not the one that we are going to use on the dynamic simulation section. Then we have to incorporate the wheels. So I recommend to do not use a joint. I would say let's use constraint and use the insert option. So we have both of those front wheels with insert in place, so you can play around. If you have noticed, my main assembly is constraint, and that's going to give us some troubles. Is ground. That is going to give us some troubles with the tangents to the plate, so don't forget to unground as I did right now. Okay, so now the tangents are going to work, and we're going to be able to put our car touching the ground. Okay, so we need to adjust a little bit the suspension system to be at the right height, and following we are going to use the save and replace command, so we can do a copy of our ground and do a modification having a 1 meter length on one of the sides, right? So in order to get the car in position, you can add this mate of 19 millimeters in between faces. That is the one for the spring, as we saw on the second video. We can then drag and leave in a correct position, our car. Note that the tangent condition is going to avoid us from steering those wheels, so we need to suppress them, but we can also use them for reset the position of the wheels and get them back into the correct position. So you can unsuppress them and then get them back as required. Okay, so you can enter now into the dynamic simulation environment. Let's make sure that all the groups and everything is doing it well and that everything makes sense. Following this, I'm going to take out of the subassembly of the arm suspensions the wheels. So the wheels are going to be dragged outside and redefining the constraint to, well, those are made in joint, and the joint should be rotational. Before it was rigid, and of course add the other wheel that disappeared because of the change. Okay, so here is the point where we require to use the tangent condition to reset our position. Let me check. There you go. So we reset the position and suppress the thing. Okay, so now that we have defined our mates, we can jump into the environment for the dynamic simulation. We are going to have this over-constrained to degrees freedom, but is something to keep in mind, but those are not going to affect, since those are not a big problem, to be honest. Okay, so very important is to make sure that you have the 3D contacts for the wheels. I believe I have a trouble with this one, if I'm not wrong. Yeah, entity is not valid. It's something rare, to be honest, but let's leave it like that. It is actually just making contact 3 of the wheels, but you will see that it is going to simulate properly. We still have the spring that we set up in the last tutorial in the chapter number 2, and we have a 3D contact in between these two parts. Sorry, I will edit. Yeah, so we have it is in between these two rolling parts that are going to be in contact. And for this type of mechanism, there are other options, and it will be one of these ones, rolling on plane. It should work properly, but unfortunately, it requires that they have a common line, as you can see here on the simulation, or on the animation. So they should have the certain diameter, and the other part needs to be straight. In this case, we have a cylindrical one, and we know that it is requiring some let's say rotating effect because of the axial point constraint in this component, right? If not, it is not going to move. Remember, it is basically because this part has some compliance, they can flex, and that's something that needs to happen in here. And since the program is using all the parts as rigid, it is hard to achieve. So yeah, okay. So now that the 3D contact is set, let me introduce to you how to drive a constraint. Okay, so we will check this when they are already worked. Let me let's go to properties for this revolution. This revolution is also, well, is given by this assembly joint or assembly constraint, so it is related with it directly. So this is the one that we need to modify. Okay, so I will click on properties, or I can double click it, and we have this remember from the first video, we have an explanation about what are these options. So we are going to use the in post motion in this one, and we will set this sign movement. So the steering wheel is going to be rotating back and forth from 45 degrees to minus 45 degrees, like someone just moving it right from one side to the other. And the way to do that is, let me actually I will remove this by saying constant value, and now I will click again in the input grapher option. Sorry, it is there. Okay, so how do I delete this? Oh, it's linear ramp. There you go. So when you open this, you are going to have the linear ramp option as the first thing. So it depends just from 2 points, and you just apply the degrees from where you want to start with, and the one that you want to finish, and the time that is going to give you a slope. Or you can set a specific slope, for example, let's say 30. So as you can see, the graph is adjusting real time. But what we want to do is to apply a sign, right? So I pick it, click on this arrow, and now I'm going to set here my values. So the first one is 45 degrees, and I want this to be repeated 4 times. So 4 hertz is the entire thing. So if I count from here to here, I have 4 times the cycle. Okay, so we can have some extra graphs without having to run the simulations, and it is basically the velocity one and the acceleration one, but there is no acceleration because everything is in constant move. Yeah, you see? Yep. Yeah. No, there is some acceleration when it is going forward, but yeah. Okay, so we have our sign defined. I will click OK, and please notice that this is in the terms of just 1 second, right? So it is pretty fast. So we can do something softer, to be honest. So we can go up to 5, maybe in 5 seconds. Whoop, 1 second, 5 seconds. This means that we may have to lower our hertz to maybe 1 per second. Yep. So it is 5 times. So maybe we can go 0.75. This 1, 2, 3. Yep. Yeah. This kind of work. Okay. So let's click OK. So yeah, our simulation now is going to be for 5 seconds. We need to update this in the simulation player. So we run 5 seconds. Notice that the steps are going to be updated automatically. That's totally fine. Okay, so the second thing that we want to drive, because now we are driving this movement, and let me push back a little bit. I will put this just in 1 second. I will do the modification just for you. Okay, 4, there you go. Okay, I will get this back to 1 second of simulation. And there is nothing else, nothing extra. So we will click go, and we can verify. Look at that. So the steering wheel is going back and forth, and there is the effect that in real life when you do it on the Lego also happens. It's kind of lifting because the wheels are not having a compensation system like the spring at the back. So yeah, okay, so we confirmed that we are getting the expected result from the simulation. Okay, now that we have verified that, we are going to come back into the construction mode. Okay, this turns back our model to the initial state. Now the next thing to modify is that I want the wheels driving this thing. So it makes sense to make it 4-wheel drive. So this is going to be, I will do the process and then I will do it 3 more times, but on those I'm going to just ramp up the speed of the
video. So yeah, let's take a look to this. So yeah, we have this revolution. This is not the one that I want. I want not this one. Okay, once more. Look at this. Okay, so we have point line, but no, point line is not. Oh, okay. This is happening because we have this as a welded group. So the question right now is, what happens if we force a flexible condition there? Or maybe there is an option for ungroup? Yeah, okay. Let's provide the driving wheel to this one. That is for sure going to work. Okay, so let's pick the wheel. I will have this revolution. Perfect. It is related with this rotational condition. And I will click on properties. And we have just 1 degree of freedom, the rotation one. And we will do exactly the same, but this time it's going to be different. This time this is an post position, maybe? No, I would say the velocity. Constant velocity, I would say, is the most appropriate thing. Maybe we can ramp up and then we leave one constant. The only thing that worries me is that I'm not sure how many degrees I need to rotate this as the velocity. So let's give a, let's say that if it on each second just runs one revolution, so it will be 360 degrees per second. We are going to simulate just 5 seconds. I will say let's do it at least 720. Sorry, it starts at 0 and 5. Yeah, so let's say it is going to be 360 times 2 is 720, and this by 2 times, I would say. Nope, no, it's fine. 720 degrees. So our slope, yeah. So this will be velocity. And then at the end, it is going to have a constant velocity in this point, as you can see. So this is just a ramp up. So the ramp up can be just 1 second. In 1 second, it is going to go from 0 to 700 degrees per second. And from there, if I click in this green yellow icon, I will be in this zone. And as you can see, it is set to constant value. If I leave it on constant slope, the line is going to continue the same slope, or module or cylindrical or free, that is like it's going to stop moving by itself, right? We're going to leave the constant value. Yeah, so that's going to be the constant velocity for this, 720 degrees per second will be our choose, and it is going to ramp up in the first second from 0. Okay, right now I'm not sure about the rotation. So it is positive, and seems like the convention says that it should be positive. And not only the convention of the right hand, it also shows this arrow. Okay, so positive value is the one that we want, I believe. Yeah, so this one is not getting in contact with this one. So let's see what happens if it is that way. So let me set to 5 seconds this one. Let me get back the revolution for the steering wheel to the condition under 5 seconds with 0.75 hertz. There you go. Okay. Let me check once more. Yeah, It's 5 seconds. All right, so let's click OK. I will update this and I will save. To be honest, this thing can crash clearly. And something extra here is not extra, is required, is to make sure that our friction is going to have a value. So I know that maybe 0.6 is going to be enough. Make some traction, let's say 7. So let's click OK. And now let's see this thing running. Let's find out. Okay. So this is starting to roll. There you go. The thing is that the front wheels are not rotating at all. Is the steering wheel changing position? I think so. Let's try to find out from here. Yeah, the steering wheel is changing position. But as long as our front wheels are not rotating, I don't believe they can have certain effect over the trajectory of our car. Yeah, we need to find out how to make the traction in all the wheels. So I believe that that's going to help us to have a better result. Maybe the coefficient of friction could be as well modified. So yeah, okay, let's stop this. Don't let it run for so much if you see that the results are not going to be what you wish, because this can take long time till it react because of the amount of data that it created. So 5 seconds is and 500 steps is a lot. Okay, so yeah, so let's find out how we can move these wheels to do not be part of this welded group. So maybe this can force in somehow that the program cannot say, oh, this is going to go as a welded. Okay, so if we have a condition for these two guys, so they are, let's say, rolling. Yep, this. And now when we come back to the dynamic simulation environment, it may do not group them. Yeah, that's it. This is perfect. Okay, so yeah, let's take a look. Yeah, we have the rotational condition. Yeah, great. Okay, so let's set these guys with the rotation condition that we have just set to the back wheel. I will change the velocity 5 seconds to 720. Yeah, then a constant value after that, and it is going to ramp up in 1 second. Sorry. Okay. Okay. Very nice. So we have the rotation at the back wheel, but this one, well, yeah, let's leave it. It's going to be a little bit more of calculation. So it is a pity to do not have the fourth. Oh no! Look at that. Is it rotating backwards? Yeah, it is. The ones at the front are not rotating in the right direction. Okay. Let's save this because this is going to be special. Okay, let's put this in position and let's go. Okay, so I have the feeling like I'm missing something, and I believe I know what it is. I will finish my dynamic simulation and I will pick the assembly of the car, and I will check the mates on it. So yeah, There you go. I did this mate by mistake, or not by mistake, because I was getting the car in the right position and I want it to be perfectly aligned. But yeah, this mate needs to go away. So let's suppress it. And this is the reason why we are not having the car changing directions. Okay, so that was not ideal. Okay, so let's now click on the play button. Okay, so I will stop this in here for make a couple of changes. One is going to be to eliminate the traction on the back wheel, and I will leave it just 2 at the front. The other thing is that I'm going to increase the coefficient of friction of the wheels up to 1, so they are not going to slip at all. Okay, so let's see coefficient of friction for these ones. Properties, yeah, I want them to be 1, to be honest. Yeah, okay, so they are 1, and I'm going to remove the condition for the driving velocity here. I will remove this check, and that makes the thing. Okay, so we have just we should be able to see 3. Yeah, there you go. We have just 3 parameters that are being driven: the 2 wheels at the front and the steering wheel connection against the system in here for the direction of the car. Okay, and after that I will leave it run. Okay, so let's open the output grapher to check one of the revolutions that we know that had been driven. So for example, let's say the number 19, I believe. Yeah, the 19 one. So let's go to 19 revolution. So how about force in this one? So yeah, it looks okay. So probably when we are in a section without with a very low force, maybe it is in a convenient way on the steering wheel. I don't know. We need to check that pattern and understand. Yeah, so maybe here it is changing direction in this one. It's kind of getting straight. Yeah, when it is going to the straight position, then it gets there, but then you have a pick because of the change of direction. This is really interesting. So this kind of things can be studied here without the need of having to build and try to get sensors and stuff like that. for the study, right? Okay, so I hope this series of videos has been interesting for you. Let me know in the comments if you want to see more videos like this one in the future, or on a specific section of this simulation environment, because clearly it is way much there are way much more topics to dive into it, but yeah, there you go.